Hello, I'm Joey Nelson, founder and president of JoeScan. I'm excited to have you join me for the Forest Products Society 2020 Virtual International Conference. Today, I'll be leading us on an exploration of the state of the art in log and lumber scanning. I've broken my talk into three sections. The first is talking about the unique challenges of scanning in sawmills and what makes them different from a lot of other applications. And then we'll get into what scanning companies have done to solve these challenges for the sawmill application. And then we'll dig into some of the best practices on a specific machine center by machine center view. Really excited to give this talk because it's something that I've been spending a lot of my life on, which is taking the technology of optical scanning and optical measurement and applying it to the formidable challenges of measuring logs and lumber in sawmills. I started JoeScan in 1999, released the first JS20 scanners in 2002. JoeScan now has more than 4,000 scanners in sawmills all over the world. The first time I walked into a modern sawmill, it kind of looked an awful lot like this picture. It was a lot of stuff going on. It was really difficult to follow. And that's just the nature of it. A modern sawmill is, extremely complex and one of the, most impressive automation achievements of the world for a number of reasons. So 3D scanning has been an important part of sawmills for a lot of years, but more and more now, 3D scanning is moving into a lot of other areas of industry. And in fact, wood products is now, as you see, just about 6.5% of the total spend on 3D scanning technology. A lot more of it now going into electronics to scan iPhones or general factory automation. And the thing about this is that the wood products has really unique needs for scanning. So while it's just 6.5%, it really depends upon that scanning in a way that a lot of other applications don't. The real big differences between most other industries and sawmill industries is that most other industries are what's called constructive. Well, a sawmill industry is what I would term deconstructive, where you're taking apart a log and making boards. This leads to a really different kind of application, where in most industries, we're looking at QC. In the sawmill industry, we're looking at optimization. So in a constructive application, the key things are that it's a standardized materials. All your bolts are pretty much the same size. All the parts are uniform. And the environment's usually very clean and controlled. And because of this, what you're usually looking for is very simple decisions. Does this pass or not pass based on a really well-defined measurement. And all the goods are of a fixed value. One iPhone is worth the same amount as the next iPhone. It doesn't matter how good a job you did making it. In contrast, for a sawmill and deconstructive, every log is unique. Because you're dealing with logs and saws, it's a brutal environment. It's sawdust, vibration, beating, wide temperature swings, anything that could make scanning difficult, they pretty much do it in a sawmill. And because of deconstructive manufacturing, what the technologies and the use of scanning is not so much on QC, although that does play a role. The real key of scanning in sawmills is all on optimization, trying to figure out how to get the most out of every log or flitch or board. And the thing about optimization is it's mission critical. It's part of your production line. If your optimization's not working, you're not making lumber. As you're breaking down a log, you're kind of experiencing very different situations. Scanning a log lengthwise is one thing. Scanning a board transverse is a very different type of scanning application. And within one sawmill, you have all of those. We've tried to simplify this down to just four of the biggest challenges in sawmills. So the first is that every log is unique. What we need to do on the scanning side to deal with that is to get a full picture. We want to see as much of the log as possible in as much detail so that we can make the best decision. And because the sawmills are brutal environments, you need scanning systems that are bulletproof, that can take a lot of abuse and continue to day in and day out deliver reliable results. And because it's a mission critical, you need it to be something where your operators can keep it running. It needs to be user friendly. It needs to be something that when something goes wrong, they know very quickly where to look, where they know how to maintain it, and they know if something is wrong. One of the big things with the earlier generations of optimization systems is, you'd put them in there and the mill, it would just be like a black box to them and a magic box, and they wouldn't know really if it was working or not until things really got out of hand. So you want systems that are easy to understand and easy to work with. And then the other thing is every machine is unique through the mill. They're all trying to measure a different part of the product and a different part of the process and help make a different decision. And that often means that you need very custom tailored scanning solutions. So in the end, you can really break it down to really just two things that you want from a scanning system. You want to minimize downtime and you want to make better decisions. You want to minimize downtime because you've got a lot of expensive machinery and highly skilled workers, and every moment you're not making lumber, you're losing money. And you want to make better decisions because in every log, there is only a certain amount of value you can get. And if you don't make every cut exactly right, you're losing part of that value. So you need scanning that helps you achieve the maximum you can get out of every log. If we go back to the things that you want from a scanner, they really fall cleanly into these buckets. You want a bulletproof scanner because scanners that break cause you downtime. You want a user-friendly scanner because not being able to maintain and keep your optimizer and your scanning system calibrated and running leads to downtime. Better decisions means you need a full picture of every piece or log or board in the sawmill so that you can make the best decision for that log or board. Custom tailored is you need the right type of scanning for that place in the mill that helps you get the full picture. So it's not the same scanner in every place in the mill. It's oftentimes a solution that's tailored to the needs of that application. As far as what you can do with scanning, I think there's a number of ways that you can really achieve these goals. One is everything on the scanning should go over Ethernet. What we've achieved is getting all of our scanning down onto a single cable that's an Ethernet cable. You need sensor fidelity. You need a scanner that measures accurately and under rough conditions. You want a scanner that has low-level hardware integration that can really push the envelope as far as seeing the darkest logs and seeing fine cracks or smaller features. You want a scanning system where you've dealt with a network protocol so that it's robust and reliable and simple for your engineers to work with. And you want mounting hardware that makes it easy to mount scanners and change them out if need be. So the technology we've moved to on our newest scanners, and I think it's something you're going to see more and more in sawmills and industrial applications, is power over Ethernet. And what that's enabled us to do is get down to just a single cable. And a single cable is a big deal because every cable is a potential place of failure. And so if you have just one cable, you have fewer failures. It makes the startups faster because there's less running wire. The conduits are smaller. It makes the troubleshooting a lot simpler because there's only one cable that it could be. If there's 3 cables, you have to figure out when something goes wrong, which of the 3 cables, or is it something else? And that really slows down the process of troubleshooting. The other big thing about Ethernet is that it's an industry standard. We started with Ethernet back in 2002, and it's really proven out over the years. the original scanners that we sold in 2002, you can still plug those into any switch and they continue to operate. And I have quite a bit of faith that even another 10 years from now, those same scanners will continue to run on Ethernet. And so you're not tying yourself to some proprietary standard that's, at risk of going away in the future. If you need a new switch, if you have a problem with your switch, you can get a switch anywhere. You can go to Office Depot and pick up a switch. And, it may not be the exact switch you'd want, but it'll probably get you going. So in the end, Power over Ethernet is a great tool to help you minimize downtime. The question on scanning is do you want it faster? Do you want it higher resolution, or do you want it in a smaller package? Yes. That's what you want. You want all of them. And with the technology today, that's possible. We're riding on the continual drive for innovation in cell phones and digital cameras, and they've done amazing things with the image sensors. We can do much faster scanning nowadays. We can get substantially higher resolution. Additionally, we can get grayscale images that are at a fidelity that it starts to make a single scanner with laser measurement and grayscale imaging for grade scanning a very real possibility. And so with all this advances in sensor technology and sensor fidelity, your optimizer is able to make better decisions. So one of the things that we've found really helps us succeed in sawmills is having a very low-level hardware integration, where we're making our own cameras, buying image sensors, and we're using FPGAs to do processing and really eke out the full performance that the sensors are possible and enable very tight timing synchronization across the whole systems. With our scanners, the optimizer is receiving real-time, ready-to-use measurements right out of the scanner. There's not additional processing that needs to be done. And this really helps that optimizer make much better decisions because it doesn't have to spend time pre-processing the data. In using Ethernet, one of the things that's also always been a challenge on that is configuration. And it's not an insurmountable challenge because there's enough people that are familiar with it. But it is something where it's often a problem where you get misconfigurations. And so we've moved to a new technology, and I think this is going to be interesting in the mills moving forward, called ZeroConf. It makes networking very plug and play so that your scanning system really just goes together and you don't need to do a lot of configuration. No configuration means there's no misconfiguration. Another thing we've really focused on our networking is designing custom protocols that are fault tolerant and very real time, so that when you do have a drop packet, because it's eventually going to happen in the rough and tumble mill of the environment, you don't have disasters. It's a very quick recovery and a minimal amount of disruption, and often will go by completely unnoticed as far as the full scanning system is concerned. And it's technologies like this that help a scanning system minimize downtime. Another big innovation we've made is in our mounting hardware. Previously, our scanners and lots of other scanners had mounting schemes that were fairly cumbersome, that required quite a few screws to be installed and a lot of hand tuning to get the alignment correct. And what we found was that this was really costing mills time, both in startup and in operation. And the fact is that, startup time is downtime. So what we wanted to do is come up with a system that allowed you to get extremely precise and reliable and repeatable mounting of your scanner so that you could get them installed and pointing in the right place with minimal fuss. The technology we came up with was based upon cameras and rifle scopes and uses a dovetail to give a very precise reference. The mount is repeatable and fast. It's when you pull a scanner out and put a new scanner in, the laser will be pointing exactly where the previous scanner's laser was pointed. And the calibration is built into the head, so it will have the same calibration. The system will be able to continue operating without requiring a full system calibration until the next break, which helps minimize downtime. So throughout the mill, you're going to be always looking for kind of the same things in order to minimize downtime. But depending on the specific application, there's different opportunities for you to make better decisions. And so we're going to go through bucking, merchandising, carriages, trimmers, flighted chain, log scanning, and edgers, and talk about some of the ways that you can make better decisions in those specific applications. So the first application we're going to look at is bucking and merchandising. It's a really important one because it's the very first place that you're often scanning a log as it's coming into your mill. Once you've made that first cut, you can't undo it. So you want to make a good cut there. One of the key things we've learned there is you want to really maximize your scanner coverage. And so having scanning on all sides of the log so that you're not trying to guess what the shape is. If you have just a single head coming down from the top, you're only really getting good measurements on slightly less than half of the log, and you're guessing on the other part. It saves you money on scanning, but it will cost you money as far as recovery. And so we're finding that having more coverage with scanners on all sides of the log is a way to improve your recovery and make better decisions. The carriage has a very similar issue. Historically, a lot of carriages have only used a front side scanning. So there's, the operator's looking down at the front of the carriage, and the scanners are just scanning that part of the log. And this makes some sense because that's where you're first going to be cutting. But one of the things that you don't always think about is that the decision you're making on a carriage is really kind of two decisions. How deeply in are you going to cut? And then what taper are you going to cut at? The taper is also going to be the same taper you're going to cut on the backside of the log, because you're going to want a rectangular cant, not some kind of trapezoidal cant. And so if you're making that decision that's affecting both the front and the backside, but only looking at the front side, you might be giving up a lot on the backside without even realizing it. So having scanning on the front and the backside enables the optimizer to reduce the guesswork and make a better overall full log decision and increase the value. Another innovation there has been the continual drive to shorten the space between lasers. So if you get your lasers closer together, that means the log has to travel less before you get a full scan, and you get the scan into the optimizer faster, and it gives the optimizer more time to make a good decision. One really challenging application for scanning in the sawmill is at the trimmer. It's very demanding in terms of accuracy. It's one of the fastest kind of moving systems, a lot of very high piece count. And what you're often looking for is a very subtle thing. The real big factor on your trimmer optimizer is your ability to tell the difference between a square edge and steep wane. This has been something that's been challenging for scanners for a long time. And the solution that we've come up with is to have two cameras. So traditionally there would be a single camera. In this image, you can imagine it just being that laser and the red line camera. The problem with that is when you've got steep wane, the top of the board blocks your view of the laser. By adding a second camera, we get a very, very clear view of that laser and enable the scanner to get dramatically better measurements on steep wane and help the optimizer distinguish steep wane from square edges. And this is, on trimmers, the key to making better decisions. The same dual camera technology is also really important for flighted chains. With a flighted chain, you have a very similar problem that if you have just a single camera, the flights will block your scanner's view of the bottom of the log because it's resting on it and the laser will be behind the flight from one camera's point of view. By having two cameras, while one side is shadowed, the other side will be seeing, and then the second you get past the flight, the other camera will start seeing. And so if you look at these images, with a single camera, we get a pretty large slice of the log that we're not seeing. And a lot of flighted chain systems, depending on the geometry, it might even be quite a bit more than this that you're missing. With a dual camera solution, all we're getting is just that thin little slice that's really the thickness of the flights. And the other advantage of two cameras is that you get twice as many measurements because you are able to scan twice as much. Each camera can run at its full rate. So you get more measurements and more data. And more data is what's going to help you make better decisions. And I've saved the best for last because this is something that I think is really exciting. For many, many years, I've been really excited about the possibilities of very, very short in-feed edgers as a way to make a lineal edger fit into existing sawmill layouts. And so this system here is a lineal edger that's able to scan the board with just 6 inches of travel. The board is placed on the belt, let go, and within 6 inches of travel, that data has been sent off to the optimizer, and the optimizer is calculating the best cutting decision and sending the solution to the saws so that by the time that board hits the saws, they've been positioned and ready to make the appropriate cuts. Lineal scanning and lineal edgers are a really great way to make better edging decisions, and you get better scan data and a more precise and reliable cut. So this is a big opportunity, I think, for a lot of mills to use that lineal scanning technology in places where they didn't previously think it was possible. So in summary, we've talked about how sawmills are a unique and very challenging environment and a process that's really different from a lot of other manufacturing processes where scanning is used. There's a big difference between the deconstructive manufacturing of sawmills and the constructive typical manufacturing process. We talked about some of the solutions that scanners made for sawmills can employ to help a sawmill and an optimizer make better decisions and minimize downtime in the mill. And we've looked at a number of the best practices on the various machine centers throughout the mill. In the end, it always comes down to better data is going to help you make a better decision. The key thing to take away here is that from scanning, you really are looking for two key things. You want a scanner that's going to minimize downtime and keep your mill running, and you want a scanner that's going to help your optimizer make the best decisions possible and maximize the amount of recovery you're getting from your lumber. So thanks for virtually joining us. If you've got any further questions, please don't hesitate to reach out. My contact details are on this slide. I'm always looking to dig in on interesting questions and problems about sawmill scanning and to help get scanning out into more mills and make it as effective as possible.